Okay, so the question here is, okay, we find the equation of the curve which passes through the point 2, 4, and for which the derivative of y is equal to x times 3x minus 1. Okay, now the first step here is to integrate the given derivative, right? Because we're trying to find for the equation of the curve. Okay, so to undo this derivative, we need to get the antiderivative, or we integrate 3x squared minus x. Okay, so then integrating 3x squared, we got x cubed. Okay, and then integrating negative x, so you got x squared over 2 plus c. Now, this is the equation, but then you still have c. So you need to use the given points 2, 4 to find the value of c. So when x is 2 and y is 4, okay, so plugging it here, okay, we just plug it here. That's why you have this. Okay, so c here will become negative 2. Okay, so again, negative 2. So therefore, your equation for this question here is this one, okay? Y is equal to x cubed minus x squared over 2 minus 2, okay? Which you are all correct, okay? That's number 6. Now, let's go to number 12, okay? Now, for number 12, we have this question from the book, given that the derivative is, or the dy over dx is directly proportional to x squared minus 1, and that y is equal to 3, and the derivative of y is equal to 9. Okay, when x is 2. Okay, so find the value of y when x is 3. Okay, so if your answer is 19, that means you're correct. Okay, but how did we get to 19? Okay, now my explanation here is a little elaborate, okay, because I want you guys to, I mean, of course, to identify the step-by-step process. Okay, now again, if it's directly proportional, your formula should look like this. Okay, in here, y is directly proportional to x. So applying it here in the first statement, so the derivative of y is equal to k times x squared minus 1. Okay, so what do we do when we have proportions? We always solve for the constant first, or k. So how do we solve for k? Given dy, or the derivative of y, is equal to 9, okay, and then given that x is 2, okay, so k is equal to 3, and then plugging k, or the value of k, to the derivative equation, or to the proportion equation, so you get this now. Okay, so this is your uh, derivative of y. Now, the question here is, what is the value of y? So y, not the derivative of y. So we need to go back to the original equation. How? By integrating the derivative, this one. So that's my second step here. So I'll get the derivative of 3 times x minus 2. So that becomes 3x squared minus 3. Now, getting the antiderivative of each. So the derivative of 3x squared is basically x cubed, because 3 here, and then the antiderivative of x squared is this one. So canceling this, you got x cubed. And then basically, the antiderivative of any constant is just this. Okay, just add x, or just multiply x. So it becomes 3x and then plus c. So this is now your equation, but then you still have c. So how do you find the value of c? Okay, given that x is 2 and y is 3 from here. Okay, so plugging it in the equation, or to the equation of y, so our c is equal to 1. Okay, so c is equal to 1. So then we can now find for the value of y. So since the question is what is the value of y when x is 3, so using the given equation, okay, now this time it's plus 1, plugging in 3 here, So y is equal to 19. So that's your final answer here. Okay, so that's the process for question number 12. Now, let me explain one more question. Okay, all right. Question number 10. Okay, it's on page 434 also. Okay, but let me explain this first before I go to um, number 15. Okay, so number 10, given that the gradient of a curve is this, x times 2 minus 3x, and that the curve passes through the points 1, 2, and negative 2p, find the value of p. All right, so we have this. So the gradient of the curve, class, when you see gradient of the curve, it's automatically your derivative. Okay, it's the derivative of y. Okay, so the derivative of y is equal to this. Okay, so what do we do first to find the value of p? First, we get the equation by getting the antiderivative of this one. Okay, so simplifying this or rewriting this, we get 2x minus 3x squared. Okay, and then so getting the antiderivative of each, so 2x becomes x squared. Again, 2 here, and then the antiderivative of x is x squared over 2. Canceling this, you get x squared. And then the antiderivative of 3x squared is simply 3. And then this one becomes x cubed over 3. And then dividing this, you got negative x cubed. And then plus c. Now, this is your partial equation. Okay, we still need to find for the value of c. Now, how do we get the value of c? You were given another point. Okay, you were given 2 points, right? So this one, you have x and y value. So given 1, 2, because okay, if your curve intersects those 2 points, that means those 2 points are part of the solution. Okay, so given that you have 1 and 2, so plugging those values in this equation, that's why you have 2 minus 1 cubed plus c. Your c is equal to 2. Okay, so our complete equation is x squared minus 3x plus 2 now. So how do we get the value of p? So we know that x is negative 2 and p is the value of y. So then plugging in the values of x, which is negative 2, in this equation, y is equal to 14. So p is equal to 14. That's for number 10. Okay. And then lastly, okay, the last two questions from your homework. So I just asked you to do a 15A and then 15E. Okay. So for 15A, so basically when you have an index outside a bracket or outside an expression, you need to consider the coefficient of that expression, right? So how do you get the antiderivative of this? So just bring down the x plus 1, and then it becomes 5 now, because again, it's 4 plus 1. And then again, if this is 5, this is also 5. But then again, you still need to consider the coefficient of x here. So that's why it becomes 3 times 5. So therefore, your answer is 3x plus 1 raised to 5 over 15. Now, if you wrote your answers like this, 1 over 15, and then you have 3x plus 1 raised to 5 plus c, that's still correct. Okay, that's still correct. So that's 15a. Now for 15e, basically it's a fraction. So we need to rewrite our question here. So we remove the denominator, we remove the fraction by moving this to the numerator and making the index negative. And then what do we do next? Okay, so you have 2 here, so just set aside 2, and then let's integrate this. Okay, so 2x minus 7 is this, and then this is negative 1. It came from negative 2 plus 1. Again, if this is negative 1, this is also negative 1. But then, since it's under or an index, so you need to consider this coefficient here. So it gives you -2 as your denominator. So you can cancel out 2 and -2 here, giving you a -1. Okay, that's why you have a negative sign here. And then making this in a positive index, so you have 1 over or -1 over 2x minus 7 plus c. So that's 415e. So Sec 4, do you have any question? Any questions, Sec 4?
No.
No question. Okay, so that's chapter 20.1. Now let's move to 20.2. Now, chapter 20.1, we had indefinite integrals. So our answers are all expressions, okay? X squared plus 1, okay? Now, for definite integrals, the difference is that our answer now is a number, okay? And then you will see two numbers here, okay? So what are those two numbers? Okay, let's look here, okay? Now, those two numbers are your lower and then your upper limit, okay? Now, for definite integrals, there's this term called limits, okay? And then basically f of x, or the expression, is your integrand, and then this is your variable. Now, how does this thing works? How does definite integral works, okay? Now, basically, you just apply the integral techniques or uh, solutions that we had from 20.1. Okay, so if you're given this question here, let's say the antiderivative of f of x from a to b is equal to, what is this? Okay, what is this big F of b and then f of a? Okay, so this one, so this is the antiderivative, okay, with respect to the value of b, and then this is the minus the antiderivative of the lower limit, okay, with respect to a. Now, sometimes, okay, so in this one, okay, I will write my answers like this. So this is the antiderivative, or this is the answer from this, okay, and then this is your lower and upper limit, okay. So let's apply this one, okay. I know it's too vague, okay. Now, let's have example number A. So evaluate the following definite integrals, okay. Now, your question is this, okay. So we find for the antiderivative of 8, okay, from 2 to 5, okay. So that is equal to, okay. So what did I do first? So I took the antiderivative of 8. So what is that? So we know that that is 8x, okay. That's 8x. And then I'll just write this bracket here to indicate my lower and upper limit. Okay, so we're here now. So do you have any question? Again, you get the antiderivative of this. That's why this is now 8x. And then just write it like this. Okay. Now, what's next? Okay, so basically, using the answer from your antiderivative, so you just plug the upper and the lower limit. So from 8x, so this is 8x. Okay. So again, the upper limit minus the lower limit. So this is now 8 times 5. Basically, 5 came from, we substituted from x, okay? And then minus the lower limit, which is still, this is 8x, but then your lower limit is 2, okay? So answering this, your answer is 24, okay? Again, the first step is to find the integral. That's what we did here. Next is substitute the limits. Okay, so again, upper limit minus the lower limit. Okay, start from 5 and then minus 2. Okay, and then what do? We simplify and evaluate. That's why your answer here for letter A is 24. Sec 4, do you have any question for this one? Okay, we just plug the upper and the lower limit to whatever, to x. Okay, that's it. Okay, so I think this one is understandable. Okay, so let's have letter B. Now, letter B is a bit more complex. Okay, so we're given this. Okay, so what is the antiderivative of 3x? Okay, okay, and then you have your lower and then upper limit. So from 2 to 5. Okay, so first step is to find the antiderivative of 3x. Okay, let's get the integral of 3x first. So we have this. Okay, I think everyone can do this now. So 3 is this, and then the antiderivative of x is x squared over 2. So this is your answer. And then writing this, and then from 2 to 5. Okay. Now, so we're now here. Okay. And then what do we do next after this? Okay, so we solve for the upper and the lower limit. So upper limit minus the lower limit. So using this equation here or expression here, so we just plug in the upper limit first. Okay, so in place of x, so it becomes 5 here, minus using the same expression or term minus the lower limit, which is 2. Okay, so simplifying this, so you will get 75 over 2 minus 6. Plus, you can just plug this in your calculator, but be careful, okay? Always double check your answers, okay? Because sometimes it multiplies 3 first and 5 before squaring, okay? But then, if you want to do this manually, 5 squared is 25 times 3, that's 75, okay? And then this is minus 6. So therefore, your answer here is 63 over 2 or 31.5. Okay, do you have any question from letter B?
No.
No? Okay. So again, get the integral and then for your answer, so upper limit, so plugging in 5 here minus the lower limit, which is 2. Okay. And then that's it. So you get your answer. Okay. So let's have another example. Okay. Okay. So we're here now. So let's have letter C. So given letter C, so we find the integral of x raised to negative 1/3 from 1 to 8. Okay. Now, first, we get the integral of this. Okay. So what I did here is I simplified this first. Okay. Because it's trickier to use this here. Okay. So I suggest, so write them properly first. Okay. So the antiderivative of this is this one. Okay. Again, this is 2/3 because 1/3 plus 1 gives you 2/3, and then again, this is also 2/3. So how do you divide fractions? You get the reciprocal of this, so it becomes 3 over 2, and then times it by x. So that's why you have this. Okay. Now, if you want to write this like this, 3 over 2 x 2 over 3, it's fine. Okay, it's the same thing. So this is our answer. Okay, and then now, what do we do next? We subtract the upper limit and the lower limit. So this is your upper limit. So using this term here, plugging in the upper limit and then minus using the same term, and then now this time plugging in the lower limit. So evaluating this, you'll get 6, okay? And then evaluating this, you'll get 3 over 2, okay? And then therefore, your final answer is 9 over 2. Okay, so do you have any question? So we're given this. So the integral of 1 over 3x squared from 2 to 3. Okay, so first, we rewrite this, okay? So it becomes 1/3 and then x raised to -2. So getting the derivative of this, you'll get this. So 1/3 times x raised to -1 over -1. So simplifying this, this is your answer for your integral, okay? Now, so we find now the upper end, I mean the definite integral for -1 over 3x. So plugging in 3 here, so upper limit minus the lower limit, okay, that's why you have 3 here from here, and then you have 2 here from your lower limit. That's why your answer is 1 over 18. That's the letter D, okay? Now, for letter F, if your answer is 62 over 5, you're correct, okay? Okay, so probably you're halfway here, okay? Okay, now, let me explain letter F. So we're given this. So we find the integral of x times root of x from 1 to 4, okay? Now, so what I did here is to rewrite this root, so it becomes x raised to 1/2. And then next thing I did is to multiply this 2. That's why I got x raised to 3 over 2. So what happens here? Okay, so it becomes 1 plus 1/2, okay? It's 1 plus 1/2. It came from this, okay? And then, so this is our new question, right? So how do we get the derivative of x raised to 3 over 2? So we basically plus 1, and it becomes 5 over 2. So same with your denominator. So how do we simplify uh, fractions like this? So we get the reciprocal of this, so it becomes 2 over 5 times x raised to 5 over 2. Okay, so this is your answer for your antiderivative. Now, we now find the upper and the lower limit, okay? So using this upper limit 4 minus the lower limit, which is 1, okay? So this one, okay. So therefore, your answer is 64 over 5 for this one, and then for your lower limit, it's 2/5. So your final answer is 62 over 5, okay? Or if you want, it's 12 and 2/5, yeah. Okay. But again, improper fractions are accepted. Did someone reach letter F? Okay. All right, so that's letter F. So it's 843. Okay, so let's now go to a more complex example. Now, what if we now have an expression like this? Okay, so what if we have an expression? We have 2x plus 1. Okay, so basically we need to rewrite this. Okay, rewriting this, it becomes 2x plus 1 raised to 1/2. You still remember this? Okay, now this is what you did in your homework. Okay, how do you get the antiderivative of this? Okay, you basically write this again, and then 1/2 plus 1, so you have 3 over 2. Okay, and then if this is 3 over 2, this is also 3 over 2, but then you need to consider the coefficient of x. Okay, so simplifying this, you'll get this one as your final answer. Okay, so your denominator is simply 3, because 2 and 2, and then that's it. Okay, so we find the answer for this antiderivative from 0 to 4. Okay, from 0 to 4. So upper limit, okay, is this. So 2 times 4. Okay. So 2 times 4 plus 1, and then raised to 3 over 2 over 3. Okay, this one came from this, so we just plug in 4 from x. Okay, and then likewise here, it's from here, then we just plug 0. Okay, so we just plug 0 here. Okay, so answering this, you'll get 9. Okay, and then answering this, you'll get 1/3. Okay, you can just use your calculator for this. Okay, so therefore your answer is 26 over 3 for this kind of question. Okay, so that's letter D. Okay, let's have probably 2 more, and then that's it. Okay. Okay. Okay, so let's first try to do number 2, letter A and B. Okay, let me just do that number 2, letter A. Okay, because I don't want to go here first because it's too complex. Okay, so please go to page 439. Okay, let's do number 2A. Okay. So from -1 to 1. So you got 8x minus 4. Okay, so how do we find the answer for this one? Okay, let's evaluate this definite integral. So this is equals to, okay, so find the antiderivative of this. So it becomes, okay, so it becomes, um, so 8x becomes 8 times x squared over 2, and then minus 4x, right? So how do we answer this? So evaluating this is 4. Okay, so your final answer here is 4 times x squared minus 4x. Okay, now how do we answer if it's like this? Okay, so we find the difference of the upper and the lower limit. So this is your answer, class, from your uh, antiderivative. Okay, so again, it's 4x squared minus 4x. Okay, how do we answer this? Now take note that this is an expression. Okay, this is an expression. So this is equals to, okay, so I need to use some brackets here. Okay, so let's have 4. Okay, basically the upper limit first, right? Okay, so 4, we use a, and then times 1 squared minus 4 times 1. Okay, okay, class, that's the upper limit only. Okay, so you need to do it expression minus an expression. Okay, and then minus, okay, it's for the lower limit now. Okay, so it's now 4 times -1, and then squared minus 4 times -1. Okay, so I know it's a bit long, Okay, so this is for your lower limit. Okay, so this is how it works, class. Okay, so I know it's long. Okay, so do you have any question, Seg 4? So the upper limit minus the lower limit. Okay, it's an expression minus another expression. Okay, so how do we answer this now? So let's evaluate this upper limit. So this is 1. So this is 4 minus 4. Right? So basically it's 0. All right? Okay. And then minus. So let's evaluate the lower limit. So negative 1 times negative 1 is 1. So this is 4 plus 4. Okay. So this is simply 8. So your answer is negative 8. Okay, do you have any question, class, for this kind of example? No question? Okay, so please do letter B. Okay, 2B. Okay, 2B. And then send it to the group after you're finished. And then that's the last one for today. Okay, 2B. Okay, please go ahead and answer letter B. Okay, so this is for your guide. Okay, I'll just keep it here on your screen. So let me explain this again. So basically you get the antiderivative of 8x minus 4. So I got 4x squared minus 4x. Okay. And then getting the upper limit minus the lower limit. So upper limit is 4 times 1, and then 4 times 1 squared minus 4 times 1. Okay, that's the upper limit. Minus, for the lower limit, so 4 times negative 1 squared minus 4 times negative 1. So answering that, your answer is negative 8. Again, let me just go through this. So we get the antiderivative of this. So in the process, your answer is x cubed minus x squared plus 5x. And then we now find for the the difference of the upper and the lower limit. So again, this is your upper limit. Okay, everything is 0 here. So basically that's a 0. And then minus, okay, so you have your negative 1s here as your lower limit. And then evaluating this, you'll get negative 7. So this is negative 1 minus 1 minus 5. That's why you got negative 7. So evaluating this, your answer is positive 7. And then that's it. Okay.